Hello, dear friends. Today I want to tell you about one smart Wi-Fi relay with an energy monitoring function. There are quite a lot of such devices on the Chinese market, but this model interested me because it has a color display. After all, you do not always want to take out your smartphone just to quickly check the current voltage, load, or consumption. Here, all the main information is always right in front of you, and you can control the device both through the app and directly from the body. Let's take a closer look at this relay. We will go through the connection and settings, check control directly from the device itself, look at the Tuya app features, try to add it to Home Assistant. And, of course, separately test and find out how well the claimed protection parameters match reality. In front of us is the Atorch KWS-303WF Smart Wi-Fi DNRail Energy Meter Relay. It takes up one place in the electrical panel and has a color IPS display. It works in an AC network from 85 to 290 volts and supports a load of up to 40 amps or 12 kilowatts. The screen displays voltage, current, power, frequency, power factor, consumed energy, and temperature from the external NTC sensor. It connects to Tuya Smart or Smart Life via Wi-Fi, and Bluetooth is used during the initial setup. There is remote control, timers, consumption statistics, and also 6 adjustable protections: overvoltage and undervoltage, current and power overload, exceeding the set energy consumption limit, and temperature. I noticed that my reviews have become too long, so I will try to make them shorter. Write in the comments whether this format is better, or whether I should leave everything as detailed as possible. The delivery damaged the box a little, but there is basically nothing inside that can break. The package includes the relay, the temperature sensor, and the instruction manual, which I have already managed to lose somewhere. The sensor connects to the relay with a 2-pin connector, and the cable length is 50 centimeters. It can be placed, for example, near circuit breakers, a contactor, or terminals inside the electrical panel, and you can configure the load to be switched off in case of overheating. In terms of size, the relay is almost no different from a regular circuit breaker and takes 1 DAN position. The differences are the color display and control buttons. On the side edge, there is a QR code for installing the Tuya or Smart Life app. 4 terminals are used for connection. The mains input is at the top, and the output to the load is at the bottom. There are separate contacts for phase and neutral, but what exactly the relay disconnects when switched off, only the phase or both conductors, we will check later. Before connecting, we must make sure that the phase is connected to the phase terminal and the neutral is connected to the neutral terminal. For this, we use this kind of indicator screwdriver. I will leave the link in the description under the video. We have powered it on, and it immediately becomes clear why this device needs a display. At the top, you can see the relay status and Wi-Fi connection. Below that, it shows voltage, current power, and accumulated consumption. At the bottom, there is the operating time, power factor, mains frequency, and temperature from the external sensor. So, if you just want to quickly check the voltage or the current load, you do not need a smartphone at all. There are 3 buttons under the screen. The left one manually turns the load on and off, and the other 2 are needed for navigating through the menu and changing parameters. With them, you can set the protection thresholds directly on the relay, without Tuya and even without the internet. Hold the relay on/off button for more than 5 seconds, and you enter the relay parameter settings menu. The plus and minus buttons are used to navigate through the menu. To change any value, you need to press the menu button, and then use the plus or minus buttons to change that value. After changing it, press the menu button again and move on to selecting another menu item and changing its value. Here you can set shutdown by upper and lower voltage. By default, the upper threshold is set to 250 volts, and the lower one to 85. The current, power, and consumed energy thresholds are not set by default, meaning they are equal to 0. The temperature threshold is set to 50 degrees Celsius by default. Below are the memory settings after a power loss. By default, memory of the last relay state is disabled. Screen brightness can be adjusted, and by default it is 80%. You can also set the screen timeout. By default, it is disabled, meaning the display never turns off. If necessary, you can rotate the display in the next menu line. An important menu item: if you have just bought the relay and the whole menu is in Chinese, then find this item and switch everything to English. There is also a separate reset for the kilowatt-hour counter. To exit the settings menu, go to the quit line and press the confirmation button, that is, the menu button. In general, all the main protections are configured directly from the body, without Tuya and the internet. Everything is clear from the outside, but it is more interesting to see what is inside the relay, what kind of power relay is used here, how current measurement is implemented, and what is going on with the tracks and terminals. We unscrew the 4 self-tapping screws on the sides of the housing and remove the side cover. Under the cover, everything is quite simple. The neutral here goes through a separate copper busbar 1 mm thick, which directly connects the input and output terminals. The phase is controlled by a separate KWS-303 electromechanical relay. The housing states 63 amps, 250 volts AC, and a 12-volt coil. So the switching here is single pole. When turned off, only the phase is disconnected, while the neutral remains connected. There are no thin PCB tracks in the power path. Neutral goes through the busbar, and phase goes through the power relay. On the main board, there is the power supply, measurement section, display ribbon cable, and Wi-Fi module. The RS485 marking is visible, but there is no external connector in this version, so the wired interface cannot be used here. And let me remind you, this is a relay, not a circuit breaker and not an RCD, so short circuit protection for the line must be separate. Now let's add the device to the Tuya ecosystem. Everything is simple here. Make sure that the Wi-Fi icon on the relay is blinking, open the app, and add a new device. In my case, the relay was found automatically and connected quickly. In the main menu, you can see the relay status and immediately turn the load on or off. Inside the plugin, the device name is shown at the top, and it can be renamed. Below that, the output state is displayed, the load is on or off. This is convenient, because the control button itself is not very informative. Next comes the relay operating timer, but for some reason it shows zeros everywhere for me. Below that are 2 columns. On the left are the current parameters: voltage, current, power, consumed energy, power factor, mains frequency, and temperature from the external sensor. On the right are the configured protection thresholds, after exceeding which the relay will disconnect the load. At the bottom, the first button is for turning the relay on and off. It reacts instantly, but visually I would like it to be better, for example, for the button to clearly change color from red to green. The next section is graphs. Here you can view statistics by day, month, or year for 5 parameters: electricity consumption, current, voltage, temperature, and power. This is really convenient for load analysis. There are also timers. You can configure automatic switching on and off, for example, to start a consumer at night during the cheaper tariff and turn it off during the day. There is also a regular countdown timer. After the set time, the relay will turn off the load by itself. The settings in the app almost completely repeat the menu of the relay itself. Here you can set the upper and lower voltage thresholds, limits for current, power, consumed kilowatt-hours, and temperature from the external sensor. Below that, you can configure the display timeout, screen rotation, and relay state after a power loss: off, on, default, or memory of the last state. There are also buttons to reset kilowatt-hour statistics and operating time. Now let's go to the automation section and see what this relay can do as a trigger, meaning in the if condition. There are really many parameters here. The most obvious one is the state of the relay, whether it is on or off. Then there are triggers based on the configured thresholds: voltage, current, power, consumed energy, temperature, and even operating time. The main scenarios, in my opinion, are voltage control and load power control. For example, if there is a strong voltage drop or overvoltage in the network, you can also turn off other devices. Or if the load exceeds the set threshold, then send a notification or launch another scenario. Interestingly, even turning off the display can be a trigger for automations. So there are many possibilities here, and from this point on it depends on your imagination and your tasks. Now let's see what the relay can do as an executor, that is, in the then block. The main function is to turn the connected load on or off. But besides that, you can change the protection thresholds, relay operating settings, and the memory mode after a power loss. One more automation example: at the beginning of every month, reset the kilowatt-hour counter to keep track of consumption from zero. Write in the comments what automations you use with similar relays and where they turned out to be really useful. let's move to Home Assistant. Since I have the Wi-Fi version of the relay for review, it can work through the Tuya integration or local Tuya. After adding the device to the Tuya Smart or Smart Life app, we go to Home Assistant, open the Tuya integration, and refresh the list of devices. After that, we look for our relay. Here it has appeared in the list. Let's go inside. Unfortunately, we only have one parameter here, and that is the switch. That means we can see whether the relay is on or off, and also control it manually or use it in automations. Parameters such as voltage, connected load power, or data from the external temperature sensor are, unfortunately, not passed here. There is an operation log, so control in Home Assistant is only minimal. Let's test the relay itself and the operation of its protections. First, let's compare the voltage. I connect the multimeter and it shows 225 volts. The relay display shows 226 volts, a difference of 1 volt. Now let's check the control speed through the app. I am connected to mobile internet, and the relay is connected to my home Wi-Fi. I press on and off, and as you can see, the response is almost instant, with no noticeable delay. Let's check the maximum voltage protection. I set the threshold to 226 volts. The threshold triggered, literally 2 seconds, and the relay switched off. In the app, the reason for shutdown is highlighted in red. In my case, this is overvoltage. Literally 2 seconds, 226 and 2, that is, 2 seconds, and the relay switched off. I will lower the protection threshold and set it to 221 volts, while the network is currently at 225. I try to switch it on. 2 seconds and the relay switches off, because the emergency threshold is still exceeded. Now let's check shutdown by maximum current. I set the limit to 5 amps and connect a regular hair dryer as the load. I turn it on, and after about 2 seconds the relay disconnects the load. We repeat it once again. I turn it on manually, and it disconnects again. So the claimed protections really do work. But it is important to understand that this is a relay, not a circuit breaker, not an RCD, and not full protection for equipment against problems in the power network. Proper protective devices must still be installed before it. Overall, the relay turned out to be quite interesting. The main advantage for me is the display. You do not have to open the app every time just to check voltage, current, power, or total consumption. You walk up to the electrical panel, look at it, and everything is immediately clear. I also like that the main settings are available directly from the buttons on the body. That means even without Tuya and the internet, you can set protection thresholds, turn the load on or off, and check current parameters. As for Tuya, everything is also fine. Control is fast. There are graphs, timers, and automations. But in Home Assistant, through the standard Tuya integration, I only got the switch. Voltage, power, and temperature were not passed there, and that is, of course, a minus. The voltage and current protections worked in my test. Yes, not instantly, but after about a couple of seconds, and for a device like this, that is normal. The main thing is not to confuse it with a circuit breaker, an RCD, or a full-fledged voltage protection relay. This is a smart relay with energy monitoring and additional protection settings, while normal line protection must still be separate. Where can it be installed? For example, on a boiler, pump, underfloor heating, charger, lighting, or any load where you want to see consumption and have remote control. But I would not constantly run it at the 40 amp limit, especially without a proper electrical panel, good terminals, and a power reserve. As usual, I will leave all links in the description under the video. If the video was useful, support it with a like and subscribe to the channel so you do not miss new reviews. Also join our Telegram group where I publish links, coupons, deals, and new smart home products. There is also a forum where questions are divided by sections, and pages on Facebook and X. Thank you all for watching. Peaceful skies, take care, and see you in new videos. Bye bye.